Hello everyone! Today we will learn autonomic nervous system, ANS. The ANS used to be called the vegetative nervous system. Its main function is to regulate the activities of cardiac muscle, smooth muscle, and glands by different transmitters and receptors. ANS include sympathetic nervous system and parasympathetic nervous system. Look at this picture. This is sympathetic nervous system. This is parasympathetic nervous system. Okay. Firstly, let's learn ANS structural characteristics. ANS is made up of preganglionic neuron and postganglionic neuron. Preganglionic neuron has its cell body in the spinal cord and the lower brainstem. Their nervous fiber is called preganglionic fiber. Preganglionic fiber enters ganglion before arriving in effector. Postganglionic fiber from the ganglia controls the effector organs. In this picture, these are preganglionic fibers. These are postganglionic fibers. Sympathetic ganglion locates in prevertebral ganglion and is far from effector organ, so its preganglionic fiber is short and the postganglionic fiber is long. Its divergence degree is high. Parasympathetic ganglion locates in effector organ, so its preganglionic fiber is long and the postganglionic fiber is short. Its divergence degree is low. Sympathetic nervous system originates from first thoracic vertebra to second lumbar vertebra. Its distribution is larger and can control almost all the internal organs. Its neurotransmitters is norepinephrine. Parasympathetic nervous system originates from the 3rd, 7th, 9th, 10th cranial nerve and from the 2nd to the 4th sacral vertebra. Its distribution is narrow. Organs such as sweat glands and kidneys are not innervated by parasympathetic nervous system. Its neurotransmitters is acetylcholine. ANS function characteristics include dual innervation on the same effector, tonic innervation, influence of the functional state on the effector. The scope of action and the physical significance are different. 1. Dual innervation on the same effector. Except a few organs, the ordinary tissue organs receive dual innervation from sympathetic and parasympathetic nerves, the action of which are often antagonistic, such as in the heart. The vagus nerve exhibits inhibitory action, while the sympathetic nerve shows excitatory action. In rare cases, the actions of sympathetic and parasympathetic nerves can also be identical. For example, both sympathetic and parasympathetic nerves can promote the secretion of saliva, but with some difference in the quantity and quality of saliva secreted. 2. Tonic innervation. The autonomic innervation of the effector exhibits tonic action in general. The sympathetic and parasympathetic nervous system are continually active, and basal rates of activity are known as tone. The tone permits an increase or a decrease of the activity of an organ. This phenomenon can be observed by cutting off the nerve. For example, the heart rate increases after cutting off cardiac vagal nerve, which indicates that, in general, the vagal nerve could inhibit the heart activity through the tonic innervation. The heart rate decreases after cutting off cardiac sympathetic nerve, which indicates that the cardiac sympathetic nerve could excite the heart activity through the tonic innervation. 3. Influence of the functional state and the effector. The peripheral action of autonomic nerve is related to the function state of the effector itself. For example, stimulating the sympathetic nerve can inhibit the movements of the non-pregnant uterus, while on the pregnant uterus it can enhance its movements. That is because receptor expression is different. 4. The scope of action and the physiological significance are different. Under condition of traumatic change in the environment, the sympathetic system can mobilize the potential function of many organs to adapt to the sudden change in environment. For example, in strenuous exercise, asphyxia, blood loss, or cold environment, the phenomenon occurs as increased heart rate. Vasoconstriction of skin and abdominal vessel, discharge of blood from the blood bank to increase the circulatory blood volume. So the activity of sympathetic nervous system is widespread. The activity of parasympathetic nervous system is relatively restricted, aiming at chiefly to protect the body, rest and recover, promote digestion, accumulate energy, and enhance excretion and reproductive function. For example, in resting state, the activity of parasympathetic system is often enhanced. At this time, the heart activity is inhibited. The pupil is concentrated, the digestive function is enhanced to promote the absorption of nutrients and to supplement energy. Okay, so much for this class. See you.